So we were talking about this 3 cross 1 system will attain any multiplexing gain or rate gain. So according to the formula, the maximum rate gain R or multiplexing gain is min of NR comma NT. So for this 3 cross 1 system, R would be 1. Then what we can more say about this? It means the maximum point to point link is 1, which is equivalent to a seesaw system. So in figure 2, the diversity order we attain through this scheme in which we are able to transmit a same bit in a particular time intervals. So we can attain maximum diversity order is 3 and maximum rate gain is 1, which is equivalent to a seesaw system. However, what about the diversity order of this parallel 3 cross 3 system? Do we attain any diversity order? No, because there would be all the antennas are used for the data rate. So we will talk about it bit later. What do you mean by diversity equals to 0? However, we can see here that whenever we achieve R, it won't be possible to achieve D. When we have a rate gain minimum, we can achieve a maximum diversity gain. So we can't achieve diversity gain and rate gain simultaneously. Whereas whenever D increases, rate decreases or vice versa. So this is a trade-off between a diversity gain and a multiplexing gain, hence known as diversity multiplexing trade-off. So we will more elaborate it. So how do we solve a trade-off? We need to provide the optimal solution which will minimize D, maximize R, or minimize R, maximize D. In between, we need some optimum solution that we can achieve D as well as R, right? So this particular formula is an optimized supreme diversity gain denoted as in the function of R. This D now is a function of R, NT minus R into NR minus R. So we know that the maximum value of R is min of NT comma NR, parallel data stream, and the maximum diversity order is NT cross NR, right? So let's explore it further with the help of this example where we have NT as 4 and NR is 6, but specifically 4 cross 6 MIMO system. Number of transmit antennas 4, number of receivers 6. So the maximum rate gain for this particular system is 4 according to this formula min of NT-NR, and diversity order Dmax is NT cross NR 24, right? So let's vary this R for 0 where no antenna is used for rate gain. Diversity order would be 24. So how do we are getting or relating these things? With the help of this formula, right? This formula, we opt R NT minus R. If we put R equals to 0 here, what we will get? NT into NR, which is the maximum D, right? And if we put the maximum value of R here, which is nothing min of NT or NR, either R would be equals to NR or NT. In both cases, the diversity order would be 0, right? So we will see the same thing using this table. Let's start with the R equals to 0 value. At R equals to 0, diversity would be maximum, which is NT cross NR, and for NT equals to 4, NR equals to 6, DR would be 24, which is the maximum. Then for R equals to 1, R equals to 1, then NT minus 1 into NR minus 1, 4 minus 1, 3, 6 minus 1, 5, 3 into 5, 15. Similarly for R equals to 2, D is 8, and for R equals to 3, D is 3, and for R equals to 4, which is the maximum, there D is 0. All the antennas are used for achieving rate gain, right? So graphically we can represent this table where this x-axis represent R and y-axis represented dr. So we can make this, it is seems like quite linear, however it is not linear. I have mentioned here, uh, it's a rough graph. It will be curved like this, right? So you can see here, as R increases, D decreases. As R decreases, DR increases. This is known as the diversity multiplexing trade-off. So we have to choose in between these 3 points according to our practical scenario, whether we need a rate gain or diversity more according to the client, right? So let's see how to design this system of 4 cross 6 uh, for the case of r equals to 2. As I told you, we need to choose in between these 3 points. So let's start with, if r is 2. What do you mean by r is 2? It means we achieve rate gain 2. So at a single interval of time, we can transmit 2 bits. So we need 2 parallel paths, that is transmitter 1 to receiver 1, transmitter 2 to receiver 2. These two paths will be fixed to achieve the rate gain 2. At r equals to 2, what would be the dr? 8. It means 8 number of independent channels, right? So from t equals to 3 and t equals to third antenna, and the fourth antenna makes 8 channel with the rest of the 4 receivers. So this will define us as, this will provide us the diversity gain. You can see here, from the each transmit antenna we have 4 independent channel to the 4 receivers. Similarly from the fourth transmitter, whereas two parallel paths, transmitter 1 to receiver 1 and transmitter 2 to receiver 2, is fixed to achieve multiplexing gain 2.